All right, everyone. Hello and welcome to Try 2, Algebra 2, Concepts A. I'm Mr. Hakes. Welcome to the first lesson. I'm excited to get through this. All right. This is section 1.1A. I'm going to break up 1.1 into two sections, A and B. All right. So we're going to have two smaller assignments, which means more points for you in the grade book. Okay. These are your notes that I'm going to go through. Right here's the warm-up. I'm not going to go through these answers. If you'd like to answer these at your own time, okay. I'm going to start right here. So section 1.1 is parent functions and transformations. Parent functions and transformations. Let's start with this. Let's start with this word right here, functions. What is a function? A function is a relation from y to x, or in some of these cases, f of x to x. Okay? We remember when we graph in Algebra 1 or 1.5, we graphed functions like y equals x, and we made a line, right? Those were functions. Functions are those relations, okay, from y to x or f of x to x. Okay? Between these two, f of x and y, there's really no difference. F of x is just a fancy way of saying the function of x, and y is what we learned, right, in elementary school and middle school. Okay, so it doesn't matter if it's y equals or f of x equals, it really doesn't matter. Okay? Now, parent functions. A parent, okay, you guys came from your parents, right? So they're the original people that you came from, right? And you are now transforming into your young self, your young adult self. All right, so your parent, a parent function is the original function. Okay, and I'll go through some examples. And a transformation is how that parent function changed. Okay, so how it changed. How it changed. Okay? Going down here. So in order for me to scroll, I have to erase this. So if you need to go back, you can rewind your video. Some goals here. Some goals are to identify functions, describe translations, and describe transformations. Okay, and I'll go through transformations and translations here in a minute. My essential question to you is, what are some characteristics of parent functions? Maybe think about that as you're going through the video. What do these parent functions have in common? I don't know. Let's find out. Down here, we have our parent functions, and we have the family to which it belongs, right? So these are what our parent functions are. Our constant, okay, constant, right here, constant, is just a horizontal line. So at any time when you see a horizontal line, you know it belongs to the constant family. Our rule for our constant family is f of x equals 1. Okay, that is our basic parent function for our constant line. Our linear family has a line, a diagonal line. There's multiple different types of diagonal lines. There's actually an infinite amount of diagonal lines, right? But our parent function, our original, is f of x or y equals x. Our absolute value family. Our absolute value family has that absolute value symbol. Okay? Absolute value in definition is the amount of units or any amount away from 0. Okay, so our parent function there is f of x equals the absolute value of x. Then we lastly have our quadratic family. And our quadratic family has that little 2 above it, or our power of 2. Okay? You can take a look at the domain and range I'm going to move on down here. Okay, identifying a function. So right here, I want to identify the family to which f belongs and compare the graphs of f to its parent function. So, looking at this first graph, what do we notice? Okay, what's the first clue to what parent it belongs to? It's this absolute value sign, right? And our parent function up there, up top, was f of x is equal to the absolute value of x. So that's our parent function for this one. All right? Now, I want to compare the graphs to that of its parent function. So if I went to Desmos, okay, Desmos, D-E-S-F-O-S, very helpful graphing application. So first, I'm going to type in my parent function, which was f of x is equal to, there's the absolute value of x. Okay? There's our parent function. This next function, what we have is 2 times the absolute value of x plus 1. So I'm going to move my graph here so it's a little easier for me to write. Okay. F of x is equal to, shoot, I don't know why it does that. F of x is equal to 2 times the absolute value of x. Was it plus 1? Yeah, plus 1. Okay. Now, what I want to do is compare these two. So our parent function is this line right here. Okay. And this red line is our transformation. And describe this transformation. Describe how this thing moved. All right? Well, just explain it to me. Is it moved? Is it skinny? Or is it wider? Everything. Describe it to me. Well, this moved up 1 unit, right? It moved up 1 unit. So up 1 unit. Okay. And then is it skinnier or is it wider? Okay. Think about that. Is it skinnier or is it wider? Well, it's skinnier. Okay, and we'll go through skinnier, wider. We'll go through those definitions in our part B. But right now, I just want you to know, or I just want you to think: is it skinnier or is it wider? And what makes it skinnier or wider? What moves it? What moves it up? What moves it down, left or right? Okay. Well, let's look. What made it go up 1 unit? It was our plus 1. What made it skinnier? Well, the only thing left with our new function is this being multiplied by 2. So, it's being multiplied by 2, that must make it skinnier. What happens if I make it a bigger number? What happens if I, just messing around, what happens if I make it like 8? Ooh, that made it really skinny. What happens if I make it 20? Oh, really, really skinny. Well, what makes it wider? Let's try a negative. Oh, nope, that flipped it. That's not it. How about something between 0 and 1? Yeah, look how much that was. Okay, now I'm seeing the relation between these graphs. Okay? So a lot of these is just messing around. Okay, seeing what changes with each graph. All right? Let's go back to our notes. 2 things I wanted to show or tell you earlier. Transformations. Okay, a transformation changes shape, size, okay, or position. Okay, good things to know here. Translations move left or right, up or down. Okay? So a translation is actually a transformation, right? Because position, right, moves its position. But a translation just takes a figure and moves it either up or down or left or right. It doesn't change the size or the shape. When the size and shape change, there's a transformation. Okay? Going down to the second one. I want you guys to go on to Desmos. I want you guys to tell me the transformation between that and its parent function. The one hint I'll give you for a parent function is this has a little 2 up here. So go back to those parent functions. What's its parent function? Okay. What's going on? Here we go. Here we're going to graph and describe the translations. So when we graph this, right? Well, let's graph it. Let's graph it first. We have our x, and in this case we have f of x. What f of x is going to equal. What I recommend doing is making sure you include some negative numbers and some positive numbers. Okay, what I like to do is I like to start with like -2, -1, 0, 1, and 2. Okay? I don't like to start at 0. I like to include negative numbers. So to solve for this, we have to plug a -2 into this function here. What is it? Plug -2 in for x. What's -2 minus 4? That's -6, right? What's -1 minus 4? Oh, that's -5. 0 minus 4 is -4. 1 minus 4 is -3, and then 2 minus 4 is -2. Plotting that. Okay, so at x is -2, we have to go down 6. So 1, 2, 3, 4, 5, and 6. At -1, we have to go down 5. So 1, 2, 3, 4, and 5. Right. At 0, we're going down 4. Well, look at that. It's basically just up 1 over 1, right? That's our slope for this entire line. So I can continue that in both directions, and there is our line. Okay? What's our parent function? What is our parent function? Well, we don't have any absolute value. We don't have a square, the number 2. Okay. Well, our parent function here is just f of x equals x. So our parent function, f of x equals x. Right? And if you go up and look at its image, it goes right through the origin, and its slope is 1. So up 1 over 1, up 1 over 1. Very similar to this new line. Okay, so I'm going to graph. There we go. We graphed our parent function and we graphed our new function. Now we have to describe its transformation. Describe it. Well, did its size change? No, it's still a line. Lines can't really change size. A line goes on forever in both directions. Okay, well, how about its shape? Did its shape change? Nope, still a line. Okay, oh, then it must have changed positions. How far down did it go? Because it's obviously moving down. At each point, it's going down. Right? At each point. So how many spaces is it going down? It's going down how many units? Down 4 units. At any given point on the parent function, if you move down 4 units, you will be on our new line. Okay? So that's how I expect you to go through these problems and your homework assignment. Moving on, this next one I will go through again. Okay, so we have f of x equals the absolute value of x plus 1. We have to graph that. So when we start with our graph, we have x and f of x. Okay, this one is very important to put negative numbers in, and I will tell you why. If we start at -2, -1, 0, 1, and 2. When we plug it in here, we have the absolute value of -2 plus 1, which is, what's -2 plus 1? Think of it quickly. -2 plus 1, that's -1, right? So -1. What is the absolute value of -1? Well, the absolute value just takes our number inside there and makes it positive. So -1, it's 1, right? If I were to do something off to the side here and I said the absolute value of -30, do you know that one? It's just 30, okay? So that's what I mean by the absolute value. So at -2, we have 1. When we plug -1 in, we'll get -1 plus 1, which is 0. We have 0, we have 1, 1 plus 1, we have 2, 2 plus 1, we have 3. Okay, so at -2, we're at positive 1. So we're right here, there's a point. At -1, we're at 0. At 0, we're at 1. At 1, we're at 2. What happens if I plugged in a -3? Just for one more point. Well, the absolute value of -3 plus 1 is -2. The absolute value of -2 is 2. Okay, so at -3, we're at 2. Okay, so this is going to go on this diagonal, and this is going to move on to this diagonal. Okay, that makes sense. All right, well, what's our parent function? If you scroll up, our parent function is what we did already, which is the absolute value of x, which starts at the origin, right here at the middle, and it goes up one space, up 1 over 1 in both directions. Okay, so it makes that v. Okay, now describe the transformation between the red line and black line. Well, did its size change? Nope. And they're both the same width. Did its shape change? Nope. 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 So it must have moved positions. How far left or right did it go? Well, from this point to this point, it's only left 1 unit. Left 1 unit. Okay, so at any given point of our parent function, if you went left 1 unit, you'd be at our new point. Okay, our new line. Sorry, I need to learn how to spell left. Looking at this one, we had the absolute value of x plus 1, but we went left. That doesn't make sense. If we went left, but it said plus 1, okay, because left is negative, and right is positive. Here's a little hint. With absolute value, it's opposite, right? So if it was x plus 5 in our absolute value, we'd be going left 5. If it was x minus 7 in our absolute value, we'd be going right 7. So it's opposite. Okay? Absolute value is opposite. All right. I'm going to let you guys do this one. Here's another hint for you on this one as you're going through it. When we have x minus 2 squared, it works kind of like an absolute value. And when it says minus 2, we're actually going right 2. Okay? Even though it's minus, we're going to the right. It's opposite. Okay? I'll let you guys work on that one and the next one. I talked about these terms, but there's another one, reflection. Reflection is flipping over a line. Okay? It's a transformation. Reflection is a transformation, and it flips over a line. Okay, that's a reflection. So when we had when we think of our absolute value, we have this nice V. Okay, there is a line of reflection there. Right, and it's right here. This green line is my line of reflection. Okay, kind of bad, but you guys get the point. And a nice thing about reflections is that at any given point on one side of that reflection, so let's say this point here, if it's, let's just say it's 7 spaces away or 7 units from that line of reflection, okay, our point over here has to be 7 units. Okay, so it's kind of a helpful thing when graphing to understanding the line of reflection, so you guys can get more than one point at a time. Okay, that's 1.1a. I'll go through 1.1b in a second video.